Hey everyone, so this is the last new lesson of the school year, which is pretty exciting. Alright, so I want you to start off by finding f of g of x, right, and g of f of x. So whenever we have an x, we're really focused on the outside function because the inside is not going to change. So I'm finding f of something, right? F of something. F is the square root of x minus 5. But what are we finding f of? F of g of x. I'm going to put g of x in there. But what's g of x equal to? X squared plus 9. So I'm putting x squared plus 9 in the parentheses. That's the square root of x squared plus 4. And that's your answer. You cannot simplify that, right? You cannot simplify that. The second one, g, is our outside. So g of equals. G is something squared plus 9. And then what's going in that parentheses? So f is going inside. And what's f equal to? The square root of x minus 5. What's the square root of x minus 5 squared? Those are inverses, so they cancel each other out. Plus 9, so we get x plus 4. Right? So our answers are different. Okay, so let's go through real quick. Additive identity. So what is an identity? Is something that doesn't change a number, right? Doesn't change a number. So what number doesn't change when you add to it? Or what do you not change? If I have the number 3, what can I add to it and it won't change the number at all? 0, right? So an identity is something that doesn't change a number. So 0 is the additive identity. 0 is the additive identity. An inverse is something that brings you back to your identity. Brings you to the identity. So if I have 3, what will bring me to the identity 0? -3, the opposite sign, right? So again, identity doesn't change a number. Inverse brings you to that identity. And so this is additive, so multiplicative, or multiplying. So what is the identity when you multiply? 3 times what? What does not change the number 3? 1, right? So 1 is the multiplicative identity. So what is the multiplicative inverse? 3 times what is 1? Remember, inverse brings you back to your identity. 1 is the identity. 1/3, the reciprocal. So the reciprocal of a number is the multiplicative inverse. Okay, so using that idea, what do you think the identity function is? What is the function that when you plug in, it doesn't change anything? So f of x equals what? It's just x, because f of 3 equals 3. F of 7 equals 7. F of x plus 8 equals f of x equals x plus 8. So the function doesn't, when you have f of x equals x, the identity function, it doesn't change anything. You plug in, you get the same thing out, right? We plug in, we get the same thing out. So to find the inverse function, right, we want to know what do we plug in and we're going to get x, right? Because again, it's a function. So an inverse of a function is when you do the composition and you get x out of it, because x is your inverse, is your identity function. Okay, so how would we find the inverse of f of x? So when I plug in, what can I plug in to 2 times something plus 8 so that I equal x? What do you think? What do I plug in there to get so it equals x? Because an inverse is when f of g of x equals x, right? We do the composition and we get the identity function out. So think about it. We want to figure out what this parentheses is, right? So what do you think we should do? Well, we could subtract 8, right? And then what? What's 2 parentheses means 2 times? And that's actually our inverse. That is our g of x. Okay, so notice what we did. If we look at the original problem, this original thing, we rewrote the problem, but instead of x, I just put a blank, and then I set it equal to x. What's another way of writing f of x or g of x? It's really y. So what we do is we actually take our original problem, we flip our x and our y, and we solve, right? So our original was y equals 2x plus 8. We take our x's and our y's, and we flip-flop them, and then we just solve. Right? So that's really all you do for inverses. So an inverse is if I start with 1, my function brings me to 4, my inverse brings me back. So it's this whole circular thing where a function brings you to something, the inverse brings you back. All right, so to write this down, to find the inverse of a function, reverse the x and y values in the function and then solve for y. So if you have f of x, you always want to put your y in first. So y equals blah, blah, blah. Then we flip it and switch our x and our y. Okay? So we always want to have a y in the problem instead of f of x. So we flip our x and our y, and then we solve. All right, so first thing is I'm going to get rid of f of x. So we're going to start with y equals 3x plus 9. That's my original. So to find my inverse, I'm going to switch my x and my y. So x equals 3y plus 9. And then I'm going to solve for y. So I subtract my 9. And I divide by 3. So y equals x minus 9 all over 3. And that's your answer. Right? So the inverse or opposite. And if you think about it, it kind of makes sense, right? The opposite of adding is subtracting. So this is subtraction. The opposite of multiplying is dividing. The only thing is you're dividing the entire function by 3. All right, so again, put our y equals in there. All right, so now I want you to pause and try this one on your own. Flip your x and your y and solve. So I have my x equals the square root of y minus 4. The opposite of a square root is a square, so I'm going to square both sides. So x squared equals y minus 4. And then I add 4 to both sides. So x squared plus 4. That's it. All right, so I want you to pause and try number 4. So I put my y equals in. I'm going to flip-flop my x and my y. And then I solve. Now this one solving's a little harder here, but we can do it. Subtract our 7. All right, so now how do you get rid of the negative 2/5? There's a couple ways to do it. The easiest way to do it is multiply by the reciprocal. So the reciprocal of negative 2/5 is negative 5 over 2. So then the 5's cancel, the negative 2's cancel. So times negative 5 over 2. And I'm going to leave it like that. I'm going to leave it negative 5 over 2, x minus 7 equals y. All right, next one. Again, y equals, flip-flop my x and my y. All right, so now this one's a little tricky. What do you think we should do to solve? So the easiest way, I think, is to cross multiply. But when I cross multiply, Well, no, never mind. Yeah, cross multiply. So 1 times 2 is 2. And then I have x times y minus 4. Now, there's a couple ways to do this. I'm going to distribute. So xy minus 4x. Right, I distributed the x. Now I'm trying to solve for y. So what do? I'm going to add the 4x. 2 plus 4x is just 2 plus 4x equals xy, and then divide by x to get the y. Make sure the whole thing's divided, though. Ran out of space. So 2 plus 4x all over x. And that's it. Okay, these are my favorite. Remember, these are easy. So now there is a notation for inverse. The notation for inverse is a little -1. That means the inverse function. So, what did we just say we do when we find an inverse? We just flip-flop our x's and our y's. So all I'm going to do is take each point and flip it. So -7, 2 becomes 2, -7. 8, 1 becomes 1, 8. 4, 0, 0, 4. 2, -6, -6, 2. And 17, -8. And we're done. That's it. Super simple. All right, so why don't you pause and do number 7 on your own. So the inverse of g is g minus 1. So I'm going to flip 1, 4, and I get 4, 1. I'm going to flip 3, -5, and I get -5, 3. Flip 8, 6, and I get 6, 8. Flip -3, -5, -5, -3. And flip -2, 0, 0, -2. Now, I actually have an issue here. Does anyone notice the issue? I have 2 -5s. That's not okay. You're not allowed to repeat your x's, so this is not a function. Right? So the inverse is not a function, so that's an issue. So this actually technically does not have, g technically does not have an inverse. Right? So there's no inverse. Technically, we can write down this version of it, but it's not technically the inverse because inverses are functions. So remember, you can't repeat your x's when you have a function. All right, last one. Graph the inverse. So the easiest way to do this is we're just going to write down all the points, all the corner points, and then flip them. So I've got this guy down here. So that's -8, -8. I've got -4, -1. I've got 1, 1. Oh, I'm going to run out of space. I've got 4. What is that? 7. And I've got 10, 9. All right. So now the inverse of -8, -8 is just -8, -8. So that's nice and easy. The inverse is -1, -4. 1, 1 stays the same. 7, 4. And 9, 10. All right, so plot those points and connect the dots. One thing I will say is when you do these, I would connect as you go. -1, -4. Because sometimes, especially if the points are a little weird, I've seen students get confused and connect the wrong dots. 1, 1. 7, 4. 1, 2, 3, 4. And 9, 10. So that should look kind of familiar. What do you notice? It's actually a reflection. If you folded this thing in half, right? It's very symmetric, right? It's very symmetric. If you folded it in half, they would actually overlap. Okay, so I want you to try this one. Now, I would add a couple extra points in here, like maybe this point, and then maybe this point. So pause the video and try this one. All right, so I've got -4. 4, negative 2. I've got negative 1, 1, 1, 1, and 2, 4. Now, the green is actually a curve. I don't know if you've noticed that. All right, so this is negative 2, negative 4, 1, negative 1, 1, 1, and 4, 2. I'm going to do it in the same color too to match. Okay, so negative 2, negative 4 is here. And then that connected to 1, negative 1. Right? So there's that. And then that connected in red. 1, 1 didn't change, right? And then that goes to 4, 2, which is kind of a curve. Okay. I think the curve should be going the opposite direction. It's more like that. Okay. That's it. All right, practice. I'll see you later.